Okay, in our notes we just saw some different ways to estimate sigma. Now let's talk about calculating some sample size. Okay, we want to estimate the average income for CEOs. We want to estimate to be correct 19 times out of 20. And we want the sample mean to be off by a maximum of $500,000. Okay, let's find the sample size required if the following situations happen. Okay, so here we're not told the level of confidence, but we are said that it does say that we want to be right 19 out of 20 times. Okay, which gives us 0.95. Okay, so there is our confidence level. Okay, so we do have our confidence level. It is, as it normally is, 95%. Some other things that we've got here is if we're talking about what the max allowable is range is, the max here it says is 62.4 million. The minimum is, of course, 0.1 million. And then, of course, we are also told the allowable error is $500,000. But let's make sure that all of our units are in the same. We've done these in millions here, so 62 in terms of millions and 0.1 in terms of millions. Let's put this value in terms of millions as well. That would be 0.5 million. Okay, so if we want to find how large n should be, remember that our formula for calculating sample size is that n should always be at least as big as your z multiplied by sigma divided by e and then squared. Okay, so we need to find, we don't have our z value and we don't have our sigma value, so let's pay some attention there. Okay, we're trying to find our z value. We know that we are going to be 95% confident, leaving, of course, 5% error left over, and we've got two tails to share it in, so 5% divided by 2 is 2.5% in each of the tails. Okay, this is a z distribution, so we can look up these z alpha over 2 values. We've seen them many times now. This is the value negative 1.96. This is the value 1.96. So we have our z values. Also, we need to find this sigma value here. Okay, so we talked about some ways that we could actually estimate sigma. We don't have any sample standard deviation. We don't have the population standard deviation. So what are we going to do for sigma? Okay, so if you don't know the population or the sample standard deviation, you can try and estimate sigma by taking the maximum value, subtracting the minimum value, and dividing by 4. Okay, so this would be 62.24. Subtract, of course, 0.1 and divide 4. We could use a value of 15.535 for sigma. Okay, finally, we can just put these values into our calculator. N should be at least as big as z value, which here is 1.96, multiplied by our standard deviation, which we've estimated to be 15.535, and divide by our error that we're allowing here, 0.5, and then we'll square it. This value we will get to be 3,708.4. When you're talking about sample size, you always round up. It doesn't matter what the decimal value is, you always round up. And here you'll get 3,709 that you should do for your sample size. You can actually do this with Minitab as well. Let me show you how to do that. You go to your stat option, power and sample size for an estimate. Okay, we are estimating from a mean. Okay, so we're estimating from a mean. Our standard deviation that we're using in this case was 15.535. We're trying to estimate the sample size, and the margin of error that we had was $0.5 million or 500,000. Okay, click on options. Make sure that the confidence level is as you want it to be. In this case, we want it to be 95% confident. Always leave the confidence interval as two-sided, and make sure to check off this assume the population standard deviation is known. You want to have that checked off as well. If you do that in Minitab, you will get the same answer that we calculated in by hand to be 3,709. Okay, let's go on to part B and C. Okay, so a random sample of 20 CEOs had an average income of 6.45 million and a sample standard deviation. So here is S, here is X bar. These are information from a sample. Okay, so if we're trying to calculate, so this is just a very small sample, but we want to see just how large our sample should be. Again, remember our sample size calculation here is that you need to have your Z alpha over 2 multiplied by sigma divided by E, and then you take the square of that. Again, we know the value for Z. We calculated it, or we found it in part A. That was 1.96. We still don't have sigma, but in this case, another method that we used to estimate sigma was we took a small sample. We found that our sample standard deviation was 2.6. And then our error that we're allowing here is still $500,000 or $0.5 million. Okay, so then we can just calculate this and square it, get the value here to be 103.876, which of course we will round up to 104. Okay, let's see how to do this in Minitab. Of course, stat power and sample size for estimation. Here our standard deviation has changed from being 15.5 to being 2.6. Okay, again, we're trying to estimate the sample size. Our margin of error is $500,000 or 0.5 million. Under options, we want our confidence level to be 95%, and we always want to check off that the population standard deviation is known. If this is true, we get the same value that we just calculated to be 104. Okay, just as we found by hand. Okay, lastly, if a past study shows that the population standard deviation was 2.4 million, we actually finally do have sigma. Our n will be calculated by our Z alpha over 2 value times by sigma divided by our error, and then we'll make sure to square it. Okay, so this is 1.96. Here we've got actually a sigma finally, 2.4, and divide by this 0.5 million. Okay, we do this calculation and you get your value to be 88.5. Of course, you always round up. This will be 89. Again, we can see this in Minitab quite simply. Stat, power and sample size for estimation. Here our standard deviation is known to be 2.4, with the rest of the criteria staying the same for the rest of the question. And here you get that the sample size should be 89.